Good morning, Cluj-Napoca. Am I saying that correctly? Because I am for the faraway land and exotic of Bucharest. So, a short disclaimer, this is actually a 100% true story of how me and my team were misusing TanStack Query. And I like how they just said that it's idiot-proof, but let's just see how this idiot can use it. And if you don't know what TanStack Query is, I am just gonna assume that you wandered in from the street and you saw some free food and someone rang a gong and pushed you into this room. Because TanStack Query is the way to handle server data, period. And it's best known for this. You taking this code where you have like a state for your data, a state for your loading, a state for your error, and then a use effect where you fetch that data, and it turns it into something very simple like this. It abstracts all of that for you and makes it reusable in all of your components. But 3 years ago, I was like this. I didn't know anything about TanStack Query. I was starting my own startup. I was building my application from zero. And previously, I worked in really large companies. And I had a bias to dislike state management libraries in general. I saw how bad things can get when you misuse state management libraries. Because you had all of these problems where there was too much boilerplate. Developers were making a habit of having complex business logic inside side effects and mutators. You had hard to debug state, and it also created a really big vendor lock-in. You install Redux, you're never gonna move away from Redux. You made your peace with God. You don't want that codependency because then it's also very hard to upgrade your framework without upgrading Redux. So when I built my app and had control over the decision-making process, I decided not to use anything fancy and just rely on good old-fashioned React context. And it worked, for a while at least. We kept the state local and small, and when we needed reusability, we were just hoisting it up a level or two so we could use it in multiple components. But at a certain point, and for us, that point was when we got to 10 developers working in sync, AI made writing code that much faster, our root file started looking like this. And I had 10 more providers that wouldn't even fit on the screen. So I think this is the point where you're basically creating global state artificially, and you're trying to juggle bananas and oranges and kiwis at the same time. So maybe it is better to use a state management library that does that juggling for you. So I asked around 3 years ago what the go-to state management library was, and everyone, my friends, all the other people that I respect and talk to, recommended to use TanStack Query. At the time, React Query, it was called. And once I read up on it, I was really intrigued by the concept and the mental model needed to really understand it. Because basically, you have to split how you think about state into two. You have client state, which is your normal UI state, models, loading, whatever, where you can still use React context. You can use state in your components, or Zustand, like a small state management library. And then you have server state, the state you get from the API, which we can cache and reuse everywhere inside of our code. And I thought, oh my God, what a revolutionary idea. I absolutely love it. It also is framework agnostic. That's why it moved from React Query to TanStack Query. So I could use it in React Native as well without much problems. So we installed TanStack Query in our project, and we immediately started using it for everything. Now, for some context, the app was like a CRM for students who are job hunting. So they track companies, they track jobs, they track contacts, coffee chats, interviews, and there are a lot of rejections in the job hunting process. And I decided to gamify the whole thing. So if we can't make job hunting more painless, at least we can make it feel like a video game. And we started adding XP points, challenges, a leaderboard, badges that you can achieve, actions you need to do, progress level that unlock different features based on what level you are, a feed. And to implement this, we have to track every action the user was taking. Every time a user sent an email, save a contact, save a job, besides doing the normal post request, like
saving the job, we also did programmatically another post request complete action, which had an action type and a payload. And once we map everything together inside of our app, we ended up with over 100 gamification actions. And each action can have side effects. When you do an action, your XP might grow. You might complete a challenge. You might go up a level when you complete an action. You might navigate to a different type of page. A model might pop up to say, hey, you are now level 3. And all sorts of notifications inside of the app. And to make this work, we built a use gamification hook that wrapped the whole system, XP, challenges, leaderboards, everything into one single hook. And then we had a couple of related hooks that help us, like use XP, that synced the animation with the server, because the source of truth was always the backend. And TanStack Query was perfect for this because gamification data needs to be everywhere. You're showing XP in the header, you're showing XP in the sidebar, you're showing XP in the leaderboard, in your profile page, everywhere. So you write only once the hook, and every component that needs it subscribes, and you're only making one GET request for that information. So we kept adding hooks, and more features, more queries, and along the way, without anyone making a decision about it, we picked up a habit. Every time a user did something, like send a message, drag a card, complete a challenge, we would fire a mutation, and then on success, we would invalidate every query that could possibly be affected. So it started with one. Every time someone did an action, we wanted to see all the other available actions because something might change, so we invalidated the gamification actions. Then two, we needed to see which challenges are available and have been completed by the user. Then we wanted to see the level the current user is in, and you get the point. We just kept adding more and more inside of this function. And after we call this function every time a gamification action happens. And there were over 100 of them, triggered from all sorts of places inside of the code base. And the problem with this is that it worked really, really well. TanStack Query did its job. Data was always fresh. UI was always up to speed. If you saw something stale, you just added another invalidate queries. And by the time we realized something went wrong, it was kind of too late. So we launched, and our business model was to sell our product to universities. And they give this product to their students so their students can look for a job. And usually through an email or an announcement when the students come on campus. So we had our daily users, then a big spike when a new university signed on. And then these new users got the email, they accessed the app, some retained, some fell off, and then again, another spike when another university came on, and so forth and so forth. And we started noticing that during the spikes, the app became unresponsive. Timeout error happens, and our database CPU was reaching 100% and became basically dead. Now, you in this room know what this talk is about and can guess the root cause, but at the time, we didn't even suspect the problem. We saw that the DB was at 100%, we followed the endpoint, and assumed it was something due to the database queries, too many left joins, no indexes on the table, API latency, stuff like that, the usual suspects. So we spent weeks and weeks fixing queries, improving backend latency, creating multiple API instances, scaling the DB, and it kept happening. And every time we had a spike of users, our DB went down. And we started getting to a point where we were scaling up the database, and we were paying like $5K per month on Google Cloud Platform. And this might not sound a lot, but 5,000 euros bill per month for only 300 users. Eventually, when nothing was working, we kept looking at the metrics and noticed one metric that stood out. We had over 1,400 requests per second on average during announcements and onboarding. And what was happening? First, the user does what a normal action in the app, like send an email. And when that happens, we were just triggering a post request. And then we invalidated directly affected queries, like the contacts, the emails, whatever the users were seeing at the point, we were invalidating. But then the gamification system kicks in. So because sending an email is an action, we called complete action if available, send email. Then maybe that email is the first email, so we were also completing the second action. Then an email, it's a message, so that's a third action we were completing. And it might have been written with AI, so that's the fourth action, and so forth. And because we invalidated after each action, we were basically invalidating multiple times. And the end result was when the user were doing something in 2-3 seconds inside of the application, we were actually making 150 requests at the time of a user clicking a button. And we started looking in the front-end code, and almost everything the user did triggered multiple actions. And when an action was triggered, we were calling this function that had 11 invalidate queries. And if I did not mention before, invalidate queries doesn't just mark your data as stale and wait around. If there's a component on screens that subscribe to that query, it does a refetch immediately. And the gamification system was all around, so it was causing multiple refetches. So you had a lot of students doing normal stuff, everyday things, sending emails, dragging Kanban cards, completing challenges, causing a domino effect of increased requests and increased DB load, and basically bringing down our app multiple times per day. And before you gang up on me after this talk, I'm not actually blaming TanStack Query or invalidate queries. Invalidating is a legit way to handle data after mutations. It's all in the docs. It's just how we used it and implemented in our code and our particular use case that was causing the problem. So what we could have done differently. First things first was our design issue. When we were calling the action 5 times at a minimum and invalidating after each request, causing 50, 60, 70 potential GET requests after each click. So for this, we built a queue. The queue was simple. We just added the actions in the array, set a timeout function that executed the queue, that flushed the queue, and we then executed all the actions in parallel, and when that finished, then we ran the invalidate function that invalidated all of our queries. And this helped a lot. Actually, it reduced our average gamification actions requests that we were taking from 66 to 11. And fun fact, after I gave this talk at Paris, Tiki Dodo gave me a proper tip that when you're doing multiple invalidate queries one after each other, it doesn't actually affect the front end at all. React Query is smart enough to just get the latest information. You're still making the request, but it's only re-rendering with the latest information, so you're not doing extra computations on the front end. And even better, Tiki Dodo tip is that you don't really need the queue that I built. TanStack Query can do that entirely for you. You just need to pass the signal to the fetch function like so. So by passing the signal from the query to your fetch functions, TanStack Query does all that work for you behind the scenes. If it notices that you have an in-flight request and you make another request for the same query key, it actually cancels the first one. So it blocks all the requests that I was making, and it basically invalidates the queue that we built. So this would also reduce the 66 requests to 11 without the need of a queue. Now, the fire was getting smaller. We lowered our DB instance twice and scaled down our API to fewer pods, and it was working most of the time. The main problem still happened when universities had workshops and people were gathered in the room like this, and everyone had their laptop, and a teacher was on stage like me, and it was telling them, okay, now go and save a job. And all 500 students at the same time clicked the same button. And when this happened, because, again, the number of requests, it was overloading the DB connections that our backend was having. And this created a wait. Requests were waiting in line to get the DB response. And students just saw the infinite loading more and more, and they were raising their hands and complaining, oh, the app is slow, the app is not working, the app is loading. Oh. So what did we do? We implemented an abort control that broke the connection and threw an error if the request was triple on average the response time. So we had a typical request would take us 100, 200 milliseconds. So if a request was taking 600 or 700, the abort controller would kill it and show an error. Now, this didn't really help that much because TanStack Query has a default retry of 3 with exponential backoff. So when the bottleneck happened in RDB, we will kill the connection, and TanStack Query will try again, then wait a second, try again, wait 2 seconds, try again, and once more. You can turn that off, either globally or for specific queries. And we think this retry was pretty useful, so we only turned it off for gamification-related queries, which you can do when you declare the query yourself by setting retry to false. Now, this helped us in the short term and solve the issue of our app is loading forever because of the DB connections. Because now we were failing fast and showed an error to the user. But unfortunately, students by nature are very persistent. And when they saw the error, they just tried again. So again, again, and again, which caused the same problem as usual. So we had to go back to basics. So every time we created a new gamification action in the DB, we returned the representational value of the entire gamification system back. So if you don't know, REST actually comes from representational state transfer. So when you create or update a resource, the server returns that resource back. So instead of having 10, 11 requests for all our gamification data, we were returning the entire system at every post request to the gamification system. So before we were just returning 200, and we changed that to return a JSON representation of the entire gamification for that user, which had all the actions, challenges, XP, everything the user needed at any given moment. Then, taking advantage of TanStack Query set query data, we updated the cache with that information. So with set query data, you can update your cache immediately. And it's a very nice way of doing optimistic updates in your application. So you don't show a loading screen while the data is being fetched from the backend. If you already have the data, you can update the query. And on API success, then you invalidate the query. In our case, we removed the invalidation completely. We got the backend data, we set it in the cache, and we left it in the cache. We assumed it was correct. And we stopped using the get endpoints for 90% of the time. We were just using them on page load. And then we were relying on the post requests. So this basically took us from 16 average extra requests to 0 per gamification action. We removed that big invalidate gamification function, and we stopped invalidating completely for our gamification. And this finally solved our problem, and our DB could finally breathe. And while this may seem simple, it actually took us to 3-4 months to get this right. So there were a couple of things we tried unsuccessfully to fix this before we came to our solution. So one of this was tail time. We looked into the DB TanStack Query documentation, and we thought that, OK, stall time is the culprit because it has a default of 0. So maybe every time a re-render happens, it causes refetches to the backend. That's actually not true. We were thinking wrongly. A refetch only triggers when a specific event happens, like, for example, window focus, component mount, the connection reconnects, or something like this. Stall time does not do immediate extra requests. Anyway, it was causing only when you were reconnecting, and it was happening in the background. Then we eliminated stall time as a culprit, and we looked somewhere else. And then we found something called cache time. And at the time, cache time, we assume control how long something stays in the cache, and it causes a refetch when it expired. This again was wrong, and I'm guessing this is why they renamed it from cache time to GC time, because GC stands for garbage collected. So this is actually the time something stays in the cache before it's garbage collected, and it was causing no extra requests. Then we found a cool trick that you can structure your keys. Before we had everything flat, and then we moved it hierarchical inside gamification. This was not reducing any refetch, but it does make invalidation explicit instead of scattered across 81 files. And when you need to invalidate multiple keys, you can just use the same domain. And this helped us a lot with our refactoring. Another tip we found is to not define query keys in line. If you do this, you think you're prefetching, but you're not. These actually creates 2 separate cache keys, and then you're no longer sharing state between components. What you should do is you should create your query using query options, and then use it everywhere, which will create a shareable cache. Then we found this super nice trick that improved our UX. So when we were doing on success, we were calling invalidate queries directly. And this this was doing, it was setting is pending false immediately. And because of this, on the UX, the user got a message that said success, but he still saw the old data until that was refetching. and it was until it was finished. So to fix this, we were actually returning the invalidate queries function, which kept the is pending to false, and our UI was still loading. Also, don't call TanStack Query hook conditionally in the component, like we did here at the top. Like, if value exists, then return data, blah, 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 use query. This is an anti-pattern. What you should do is use the enabled option, either when calling the query, or better yet, inside the query's options like I showed before. This guarantees that your request won't fire until the enable flag is set to true. A final tip that I think works really amazing with TanStack Query is that you don't have to actually write all that query functions and utilities yourself. You can actually automate everything from the backend schema. So we did this in our company now because we have a different backend than frontend, so it's not TypeScript. We don't have TRPC. So we're generating open API schemas, and from the open API schema, we're using a tool called Orval that generates everything related to TanStack queries in our application in one big client file, which we can import inside of our application. That way, we don't have stale hooks, we don't have things we are not using. Everything is up to date using our backend. I actually built a fun side project recently where you're just declaring your data in Prisma schema, and it generates Zod types for you. It generates the crude API request for you. Then it generates the open API schema. From there, with Orval, it actually generates the TanStack query code that you can use into your UI. And then it finally generates an admin panel based on all of that combined. I was trying to replicate how Django does it, the Python framework, and I thought it was really, really cool. Now, I hope my real-life example makes you think twice about how many requests you're making, and at least make you go open your app and network tab in developer tools and see how many requests you're making on initial page load, and hopefully optimize some of the requests. Now, if you're a little curious about me, I've been coding for 15 years already at some cool startups like Glovo, Rover, Dormy. And because I'm closing in on 40 years of age, I am required by international law to start a podcast. I host Seniors at Scale, and I was privileged to have so many cool guests on my show, Dominic included, and talk about scaling software and libraries and open source. So if you're interested, check us out on Spotify and YouTube. And finally, if you're interested in security, and you should, if you are not aware what happened this week with TanStack, just yesterday, Next.js had another vulnerability. So if you're using self-hosted Next.js, you need to update immediately. It's a big problem. But I do have a free security course for front-end developers with a couple of modules out. So if you want to learn how to protect yourself and your company, check it out. And with that, thank you so much.